Before we have the break, we still have two speeches here. So maybe we invite the first speaker, our distinguished guest from Germany. Okay, let's welcome our Dr. Hans to give our very good speech here. Thank you.
Thank you. Professor Chu, thank you very much for introduction. And thank you very much, especially for inviting me to participate in your Congress today. Thank you very much. I want to present you anything about our research activity in the field of biogas and the activities of Germany in this field. And we have done a lot in the last years. I'm coming from the State Institute of Agricultural Engineering and Bioenergy. This is an institute at the University of Hohenheim. And here you can see the map from Germany. And Baden-Württemberg is the state where I'm coming from in the southwest. And the town where Hohenheim is located is Stuttgart. If you compare it to the size of the area, the size of Baden-Württemberg is nearly the same like Taiwan size, but we only have less than half of the inhabitants there. So you are much more crowded than we are in this area. And a lot of you will know Bavaria maybe, with Munich as main town, also Berlin here, and Hamburg, main cities in Germany, to give you an orientation. Baden-Württemberg is a very nice country with a lot of culture. You can see a nice landscape, but on the other side we have also a big number of famous brands like Daimler, Porsche, SAP, Merck, and so on. You will know some of them. And a lot of engineering is there found to find. Yes, the University of Hohenheim at Stuttgart. It's an old university funded more than 200 years ago, 1818, after a hunger need in this region when we had an eruption of a volcano in Indonesia, and it brought a lot of darkness and bad harvests, and so there the king of the former time funded this university. Today we have three faculties: agriculture science, natural science, and business and economics. And totally around 9,000 students, the staff 2,000, and academic staff around 1,000, less than 1,000. This is not the only university of Stuttgart. We have also engineering university and other topics at another university. Yes, here a view onto the university. The campus is very nice, with the castle as main building. This is from the former king who funded the university. We can see pictures from the gardens and also from a festival there. And on the right side, we can see some of our equipment for researching in the field of biogas, simple batch tests for looking for the methane yield, continuous running systems to make systematically analysis. And we have, or we are glad to have a full-scale biogas plant where we can make in a very big level examinations for the farmers, which are our colleagues. This is a group of my team. We are around 25 persons, and yes, this is Hans Koh from Professor Chu's team, and also Chechen, and Raymond was not available at this day of the photo. He was also there. Yes, I want to show you an overview about some aspects, situation and challenges of biogas, alternative substrates, efficiency and flexible biogas production, which can be important to support energy, biomethane upgrading and fuel, and some bioeconomic concepts. I don't have so much time to each of them, but the actual situation is that we have an increase of electric consumption or production from renewable sources over the last 20-30 years, and at the moment more than 60% of the consumed but its share is very low. But wind power is very important, photovoltaic, and also biomass. Biomass allows us to be flexible compared to wind and solar, which are coming when wind is coming up, sun is shining. Biomass has around 10% of the totally electricity consumption at the moment. This is very interesting. So at least the renewables are 255 terawatt-hour per year, which are produced from this source. Political aim is to come to 80% up to the year 2030. Biogas is shown here, and we can see at the columns the biogas plant numbers, and these are mostly big biogas plants, an average of 450 kilowatt electric power. And on the green line you can see this is electric power, 3.8 gigawatt installed power, which is necessary to burn all of the produced biogas, but we have bigger power or higher power available, so it allows us to produce electricity flexible, so adapted to the need of the grid. And most of the biogas plants in Germany are running as heat and power units, so they burn the biogas, produce electricity and heat for the surrounding. Different from Taiwan, we need a lot of heat, especially in winter time, for heating the houses. We have a few of our biogas plants equipped with upgrading systems, so take out the CO2 from the gas to bring it into the natural gas grid and to use it later. Some aspects of the existing biogas plants, they mostly are running in a CSDR system. Few are simple step systems, very small, but mostly we have two or more digesters in series to optimize the system. We have gas-tight storage of digest state. This is important to cover it and to avoid uncontrolled methane and other emissions from the tanks, to protect the environment. The organic loading rate is the feeding level. It's broad spectrum available. Average is around 2.5 kilogram volatile solid per cubic meter a day. And the retention time of the substrate in such a digester is relatively long to be sure that all of the organic is not formed to methane. Normally it is in a level of 150 days in an average. And the electric power of the systems is also very different. Small plants up to very big plants with 2 megawatt. It's a broad spectrum. And these 230 gas upgrading systems are very big. It is only economic in a very high level, so more than 2 megawatt is necessary at this biogas system to get economic conditions. And important, more and more of the plants are running flexible, so they can really produce electricity in this time when sun and wind is not available. Here are some pictures of biogas plants. They are constructed of concrete, often sometimes of stainless steel. We have horizontal, but mostly these vertical and CSDR systems like you know them. We have only a few units who are running in a solid fermentation, mostly as batch system, like garage or like covered tanks where we fill in the solid material. But this is not very common in Germany. Sometimes for bio-waste, sometimes for solid manure, but the most is done in liquid phase. What is with the products which are used? We can use very broad spectrum of substrates. Liquid and solid manure is very important. The disadvantage is that only 30% of the produced manure in agriculture is used in biogas systems, so we have to increase this share. We are using a lot of energy crops at the moment. 50% of the input is coming from energy crops. The production needs also work and needs arable land. Yeah, but it's economic under special conditions. We try to increase the share as a use of byproducts and organic waste. By using of these byproducts and waste, we have often the problem of the high fiber content, and so we have to solve the problem how we can get a good transformation rate of fiber-rich material in the biogas system. I will show you later some aspects. Grass silage can be one important source for energy production. Grass silage we are producing, or we produce a lot of grass, and one aspect is that the population of cattle is reduced in the last 25 or 40 years here shown. So no one needs this grass, and it's a good possibility to use it for the biogas system to produce energy out of it. And it's a very important aspect to conserve this landscape, because if we don't cut this grass, we will get wood, we get forest, and this is not so nice for the landscape to have it closed. I want to focus on another substrate which is possible for the biogas system, horse manure. We have a lot of hobby horses in Germany, riding horses, 1.2 million horses with a lot of manure production. So at least we could use such a material as a raw product for the biogas production problem. Again, the structure and the poor fermentability. Therefore, we tried to pre-treat the system by a crushing unit coming from the recycling industry for rubber or for wheels and such things. But it's also usable for this biogas substrate. Another system we are using is the ball mill. It's a system which is also crushing the structure, and we can get from this long structure horse manure fine fibers, small fibers which are able to transform in the biogas process. And this is our research plant again in full scale. It exists out of two main digester lines, fermenter 1 and fermenter 2. And in this, we can compare two variants under the same conditions. This plant has an electric power of 350 kilowatt. This is nearly the average of the plants in Germany. And the digester volume, each 800 cubic meter, and temperature more than 40 degrees centigrade. And this system is equipped with the two digester lines, with the control of the input of substrate continuously, the weight and the quality, and also the quality and the composition of the gas and the volume of the gas is measured every day or every hour continuously. And one of the system is equipped with a crushing unit, the other not, and so we can compare the substrate. And our mixture, which is brought into the digester, is shown here: 40% liquid manure, around 26% solid manure, with the main part of horse manure, and the rest is energy crops from grass to maize and so on. And each digester is fed with the same volume and the same composition. But one is crushed and one is not crushed, and here you can see the results. The system without pre-treatment, over the control period of half a year, we could see that the methane yield, the specific methane yield, decreased continuously and brings mechanical problems in the system. And the other one, where we have the crushing and the pre-treatment, the methane yield increased continuously, and we had better conditions and more efficiency and a higher methane yield out of the whole process. Yes, let's come to some aspects of efficiency. Efficiency is very good connected to the consumption of energy of the households and the industry. We can see in this red line the consumption of electricity, which is changing from the day to the night, for example, and we can see the composition of the energy sources if we don't use fossil energy. This is a view into the future. And you can see under normal conditions, we can get equal situation. We can use solar energy, we can use biomass, and we can use wind energy and hydropower very well to produce all of the consumed energy for the day and for the night. The advantage in the night, we don't have solar energy, and there the consumption is lower. The problem can be, for example, at the weekend, when the industry is not consuming energy, so we have an overproduction. And also, if we have special times without wind and without sun, there is also a need of buffering. And there's a question how we can do this. We made examinations with different technologies, with different digester types. For example, such fixed bed digesters, which are also used sometimes in the industry, with a fixed bed where the microbes can settle down and are fixed and not flushed out, especially if we have very thin substrate. On the bottom you can see the feeding input. It can run at a low input, but if we increase suddenly this feeding density, the process is not inhibited like in CSDR systems, where we get very quickly problems. But in this system, we can increase the methane yield quickly in a few hours, and then we can stop it again, and the methane production falls down again. And this is also an advantage if you want to produce the methane in time when the industry needs more energy, for example, and we have to store only the raw product before in tanks, and then we can run such a system. We tested also with this bad material horse manure if we have possibilities to increase the flexibility, and we saw here is an overview of 2 months of the two digesters. Digester 2, the red one is untreated, the black one is with pre-treatment system, and one aspect was we have a higher methane yield from the pre-treated system, like we have seen it before from the other crushing system, and we have a much more or higher flexibility by producing. We can forecast what will happen. Here is the untreated system, digester 2, where we don't have a real kinetic, but if we look to this digester 1, the same input, totally different. So we can say if we want to have in, for example, 4 hours, more electricity, more biogas first, then we can feed at a special time to increase the methane yield. This is one of the aspects. Yes, we have also the possibility to upgrade biogas. Biogas exists mostly of 55% methane, the rest is CO2. If we produce a lot of wind and solar energy, we can have an overproduction in some times. And what will we do with this overproduced electricity? We have the chance to transform it by electrolysis. Hydrogen can be put also into the gas grid, but only in a low level. But we can put this hydrogen also in the biogas process. There is a Sabatier reaction. Hydrogen plus CO2 gives methane, and we have tested it, and it's possible to transform the hydrogen together with the CO2 of the biogas process to more methane, and at least after a past cleaning system, we can put it into the gas storage pipes to have it stored, for example, from summer to winter time, or also in few hours, and can take it out again if we need it, or we can also use it as fuel for cars, for example. And in our research equipment. We have seen it before as SCHEM. Here are these two digesters, two digester lines in natural photo. We have installed such a pilot plant for upgrading of the biogas with this biological methanation process, and also to produce CNG and LNG as fuel, and may test it. So here we can see some of the equipment there, the electrolyzer and the methanation reactor, which is installed there. And we clean up the gas, at least the last maybe 5 to 10% of CO2, which is still inside, is taken out to be able to press it into the gas grid or to use it as fuel. And therefore we are making examinations with, for example, buses. Why buses and not agricultural machinery? Especially if we want to use LNG, which is cooled down to 162 degrees centigrade. It's a problem if the machinery is not running continuously, always. So we will lose our methane again. But if we use such consumers like buses or heavy transport machinery like lorries, then it's very good to use this LNG. And the concentration or the content of methane or of energy inside of this LNG is much higher than at CNG, which is also possible to use in normal systems. Let's come to the last aspect, byproducts. Additionally to the biogas production, we can combine this fiber production with biogas, for example, from special energy crops, which are flowering, which are positive for the environment, these nice plants, but their disadvantage is that they have a high fiber content. Or we can use this bio-waste, special collected bio-waste from households, and we are using their pre-treatment system with steam explosion, upgrading or heating up at 150, 170 degrees centigrade under pressure, then exploding of the tank, and the fibers are divided from the cell ingredients. The cell ingredients will come to the biogas process, and the fibers will be used, for example, for producing of paper or cardboard, or if we take waste, for the producing of small plant pots where you can buy your plants for the garden, for example. Yes, in one project we are doing together, we look for the peat production. A problem is that we have a lot of horticulture in Germany and a lot of peat which is coming from natural sources, which hinder the environment. And so we want to substitute this material by recycled material to have better conditions for the environment in the future. Let's come to a short summary. Manure, organic waste and byproducts are optimal substrates for the biogas process. Lignocellulosic biomass is the most common energy source worldwide, but we have seen the problem is the structure of this material, but we can break this structure, we can find solutions. Substrates are shown here, again. Yes, we can break the material with special systems. We have to look very good for the efficiency of the biological process. This is not always done in practical biogas plants. We have seen it in controls. The fermenter concept and the substrate must be well matched to each other. If not, we have problems and ineffective output. Biogas is usable in heat and power units very easily, but it's also possible to upgrade it and bring it to the gas grid or use it as fuel. And some of the farmers already started by using it as fuel, but only a few number. It's the first step in this direction, because the heat and power systems had been supported in the last 25 years very good. So this was a reason why the biogas number is increased. But now the government stops or reduces the support for this heat and power unit. So the farmers try to go more to these systems with fuel. We can get a closed CO2 cycle at such a system. This is a very big advantage. And biogas is a good supplement for fluctuating wind and solar energy by increasing the share of electricity from renewable sources. And we have also bioeconomic concepts available which are relevant to substitute fossil resources and also to bring separate income for the farmers who are working with this field. This was a short overview about the biogas situation in Germany, only a few aspects. I hope it was interesting for you. Thank you very much for your attention. And if you have questions, I will be available. Thank you.
Okay, thank you for Dr. Hans' speech. I think we still have 5 minutes for the Q&A section. So, any question from the floor? Yeah, I think, okay. Yeah, Professor Xie.
Hi, Professor. Thank you for your wonderful presentation. I'm Cindy. I'm from Office of Sustainability. To be honest, I know little about the technical parts. I'm learning from Dr. Zhu and all the teams. But I'm wondering about the social aspects. You just mentioned that in Germany, there is a political goal to reach some kind of 70% of renewable energy by a certain year, right? I'm wondering how in Germany, the government or maybe people like you from higher education turn the political purpose into social awareness so that everybody can be aware of this issue. I was amazed by what Dr. Zhu said that like in Germany, there are about over 10,000 biogas plants. But okay, in Taiwan, we just got started, less than 10. And most of the biogas plants in Taiwan are from these people. And as a teacher from the university, I'm wondering how we can learn from your country to make this kind of wellness be available to especially community residents and especially young kids from schools, something like that. Okay, thank you.
Yeah, thank you for this interesting question. It's a difficult question. We had a lucky situation. We had around 20 years ago a constellation of a Green Party together with Social Democrats, and they started with this development. Every party, or nearly every party, only the nationalistic, extremely nationalistic party, they say we don't have a problem with environment, we don't have a problem with CO2 in the environment and so on. But most of the parties agree that we need a change from fossil energy to renewable energy and from fossil sources to renewable sources. And therefore they put the way in this direction. And at the moment they stop it a little bit because the lobby of energy production is also active. And if you hear the sounds from US, for example, that don't have with CO2, influences also the thinking there, because this renewable energy is mostly a little more expensive, especially at the beginning, than fossil fuel. Fossil fuel you can use without to look for the negative results. But meanwhile, we have seen that solar energy is much cheaper than fossil energy and has no environmental disadvantages. So we can find, or we have the chance to, to tell the people that it's a better way. But it's a discussion in the society, no question. We have to battle always to bring more and more people on this side. And especially if energy is getting more expensive, then we don't have a chance. We will be blocked.
I think we have to learn some of the policymakers in Germany, you know, because in the first beginning, they can give a very good fit in tariff rate in Germany. That's why they can set up this kind of the biogas plant a lot in Germany. Right now, it's reached around 9,000 more, right? But depends on the landscape in Taiwan. At least the Taiwan needs 200 more, right? Yeah. So here we can create the alliance here. So maybe we can think about the future in Taiwan. It's like Germany's idea. Okay. Then
I add one sentence. It is also an important aspect, social aspect for the rural area, because we had often a problem for the farmers. The young farmers had not been interested to take the farm from their parents. So with biogas, they could earn money, and this was an aspect to stay there in the rural areas and to have more working places there. And a lot of working places are especially also in this field of renewable energy. This is also important.
Okay, any other question? Yeah, okay, yeah. But you can speak in Germany, no problem. Yeah, okay. Yeah.
You forgot to mention that we also have one problem in Germany, because 20 years ago we shut down all the nuclear power stations. Sorry? We shut down all the nuclear power stations. So we need electrical energy. And
so but I don't think this is a problem.
It's not a problem, of course. Yeah, it's very nice for you. Yeah.
Yeah. Yeah, I think the risk of nuclear power, we know it. And if I heard right, also Taiwan is planning to switch off the atomic power plants.
Yeah. We have no nuclear power right now. Yeah.
And we have also switched it off in the last time. Yeah. So. In Taiwan, yeah.
Yeah, no more nuclear power right now. Yeah.
Yeah.
Taiwan is a very small land, and not no large area of land. Germany, for example, they have a big land.
But you can also use the bio waste or the organic material first. Yes. In Germany, we have taken the way with the energy crops. This was also an advantage because we had an overproduction of food in Germany, in Europe, and the prices fall down for the farmers and so on. So this energy was a good situation in this time, but maybe in future it will change. But now we have a big number of biogas plants. We have also a big number of photovoltaic on the roofs and also in the landscape sometimes, and also wind power. But we have to increase it, yes, no question.
Yeah. Okay.
You see different.
Okay, thank you. Yeah, 大家可以看一下哦，就是说，其实在台湾很少有这样的，因为以他们学校来讲，他们是 full scale 在做实验的，full scale， 他们这一做大概养活27个研究员了，哦，因为他们趸购汇率非常高。那他们一开始以台币来讲，他们大概是10几块钱哦，1度电才慢慢降到现在大概9块多。我们台湾不很奇怪，我们早期是2块多钱，还比那个一般的钱还低，现在才涨到7块多，正常应该要10几块再往下降，对，是这样。所以这大概是一些政策的问题。不过现在我们到7块多，大概已经有比较多一些机会大家如果有机会，我们可以往这边走。那还有一个就是你可以看它这边所有的设备，如果台湾要做，大概也很难就是说size 都很大。然后我们如果说台湾的产业也愿意来把这边导入，那我们台湾就可以来做，那再往东南亚发展那这是一些想法和发展。Okay, thank you for that hands. Yeah.
Thank you very much.